So for this first problem that we're given on this page, it gives us a scenario. It says, graph each of the linear equations. Okay, it's actually not giving us a scenario, it's just giving us a problem. Give each solution as an ordered pair. Check the point of intersection by substitute. Okay, so there's a couple things we have to do. We have to graph. Let's see, I'm going to circle it. We're going to graph. We got to find the solution. And we have to check it. Okay, so there's three things we have to do. Let's first graph that first one. Now the first one says y equals 2x minus 10. Cool. I know you know it, but I'm just going to go through it, okay? So minus 10. So we're going to go down to negative 10 because that's our y-intercept. Slope-intercept form is y equals mx plus b. And if it's in this form, then we can just say that's our y-intercept, that's our slope. So that's our y-intercept right there, and that number 2 is our slope because it's right next to the x. So I go down to my y-intercept, which is negative 10. My slope is 2. I put a 1 underneath it so I can graph it. So I go up 2, up 2, and then right 1. So up 2, right 1. So I put a point right there, and then I keep doing that. Up 2, right 1, up 2, right 1, up 2, right 1. And whenever, I don't know, most of the time you don't have to do the whole length of the graph, but since we're trying to find where the lines intersect for the system of equations, I recommend doing the whole graph. And so I do the points all the way, and then I gotta connect the points. So that's the first equation. That's y equals 2x minus 10. Okay, now let's graph the other one. The other one has a slope that equals negative 3, and we have a y-intercept that is 5. The slope is right next to the x, always. And so we go to 5, which is right here. And then we say, see, it's negative 3. I'm going to put a 1 underneath it so I have a run. So it's down 3 and right 1. So that's negative 3, right 1. We put a dot right there, and we keep doing it. Down 3, right 1, down 3, right 1. Down 3, right 1. Actually, this is our answer right here. That's where they intersect. Yeah, because yesterday when I was doing it, it's actually right there, still there. It was not a perfect graph. Now, what is this point? Because that's our answer. It is 3, negative 4. So that is the solution to this system because that's where they intersect. So we did the graph part. All right, let's. We got the solution. Now let's check it. Okay, so to check it, what you have to do is you have to take this point right here and you have to plug it into these. So don't forget, this is your x and that's your y. So to do the first one, it would be, what's the y again? Negative 4. Negative 4 equals, let's see, that's 2 times x. My x is 3 right now, minus 10. Okay, so here are the two numbers that we plugged in, the 3 and the negative 4. We plug it into the x and the y. Now we simplify. Okay, so someone just asked, how do you do that? See this equation right here? Y equals 2 times x minus 10. That's the same. See how they're the same equations. So there's the 2 and there's the minus 10. I just plugged in the 3 for the x and I plugged in the negative 4 for the y. After that, you're testing it. So you have to simplify the side to see if it equals the other side. So we have negative 4 equals, this is going to be a 6 right here, and subtract 10. 6 minus 10, what's that give us? 6 minus 10 gives us negative 4. So it checks. It works for the first one. So now we got to try the second one. Let me go ahead and write that one out first. So here's the second one. The second one is y equals negative 3x plus 5. Alright, so we got to plug the same point into this one. So I'm going to say y equals negative 3x plus 5. Okay, what was my x value again? It was 3?
3, yeah.
Yeah, right here. And then my y value is negative 4. And so now I simplify to see if it works. On this side I get negative 4, no more parentheses over there. Right here I multiply those, I get negative 6, and I add the 5 to it. Wait, is that right? Oh, that's not a 2. What is that? That's supposed to be a 3, right? Oh, okay. Sorry, I wrote it wrong. So negative 3 times 3 is negative 9, and then we add 5. And then we check to see if it's true or not. Negative 9 plus 5, what does that give us? Negative 4. Oh, there are different signs. When they're different signs, remember, when they're different signs, you have to subtract. So it checks for that one too. That means our solution is correct. If our solution is correct, you move on. You're done. That's your solution. Okay? It's kind of like cheating. You can always check your solution with systems because all you have to do is plug them in.